Hello, once again, ladies and gentlemen, and welcome to our virtual classroom. Today, we're going to be going over Activity 17, which is everything having to do with ratios. And a ratio, if you can remember, is simply a comparison between two things. I might be asking, what is the ratio of boys to girls in a classroom? Or what is the ratio of girls to the total number of students? What is the ratio of those who bring their lunches to school and those who do not? It literally could be anything as long as it's two different things. And so that's exactly what we're going to be doing in this assignment. For example, if we open up our submission, we see that we have to do number one, and we have to write a ratio. We have to write a ratio three different ways. Now remember that there's always three different ways of showing a ratio. We have a fraction. For example, I could have 1 to 2. I can write that using a colon, 1 colon 2, or I can write it as a word. Put 1, the word 2, and then 2. Now, obviously, that has nothing to do with number 1, but this is just the three ways of showing a ratio. For example, here it's saying write a ratio to represent the number of boys to the number of girls. In other words, we need to have boys on top and girls on the bottom. And ask yourself, why? Why is boys on top here? Why is girls on the bottom? Well, it's because that's exactly what they're asking for. They asked for boys first and then girls. Now, if it said girls to boys, then you would put girls on top and boys on the bottom. But notice that we are looking at this table. Make sure that you put boys on top and girls on the bottom. So here I see the ratio of boys to girls. Boys is 15. I know it's the second thing, but it's actually, but this is what needs to go on top. So boys would be 15 and girls would be 12. 15, 12s, 15, 12s. Normally we can simplify that, but in our activity today, I think it's asking not to simplify. So let's go ahead and put that on our Schoology submission. So just click on the blank and it says boys is 15 to girls 12, 12. And again, 15 to 12, 15 to 12. I notice that now we have it written three different ways, and all three mean the exact same thing. And we're going to be doing that for the next problem, I believe, also. Notice that now they're asking for the ratio for 310 heartbeats per 5 minutes. So that's a ratio. That's two things that we're comparing, heartbeats to minutes. B, $68, so dollars for 8 hours, dollars and hours. And then here we have work 40 hours in 5 days. So those are three different ratios, and you're simply going to write those in each of the blanks for these following problems. But let's go on to number 3. I find number 3 to be quite interesting. All right, number 3. Number 3, a recent study shows that out of 100 pieces, so that's the total number of pieces, out of 100 pieces of a popular multicolored snack, there will usually be the following number of pieces of each color. So notice that out of the 113 of those will be brown, so 13 out of 100. Yellow is going to be 14 out of below 100. Red is 13 out of 100. Blue is 24 out of 100. Orange is 20 out of 100. And green is 16 out of 100. And we're being asked to do letter B. If you go to Schoology, notice that we only have to do letter B for number 3. So let's read number 3B. It says, if there were 500 pieces, how many would be red? All right, so let's think about what's happening here. We have a total of 100 pieces. We have a total of 100, and we're asking about the red ones. Okay, so what fraction out of those 100 are red? So remember, let's write down the things that we're comparing. So we're comparing the red ones to the total number of pieces. And this is what I expect to see in your notebook. We want to write the fraction in words. Firstly, what are the two things that we're comparing? No numbers yet, just the two things. And here we're comparing the red ones to the total number of pieces. All right, now let's write down the ratio of red to total number of pieces. So we have 13 red out of a total of 100. 13 red out of a total of 100. Excellent. But they're saying, well, what if we had a total of 500 pieces? How many of those would we expect to be red? So if the total is 100, we have 13 red. If the total is 500, how many red would that be? Well, ladies and gentlemen, let's go ahead and solve this ratio. Now, there's two ways that I've taught you to solve this. The most recent one that we saw was you can cross multiply to make an equation and then divide. But this one is actually quite simple because you can ask yourself, what can I do to 100 to make it into a 500? Can't I multiply that by 5? So 100 times 5 will give me 500, right? So if I want to make an equivalent fraction, I have to do the same thing up here to the numerator, to the 13. So if I multiply the denominator by 5, that means I must multiply the numerator by 5 as well. 13 times 5 will give me x. 13 times 5 will give me x. So let me work that out. 13 times 5, which I know to be 65 actually, is going to give me 65. So that means that if I have 500 total pieces, 65 of those will be red. And so that's exactly what you would write on Schoology. All right. Now, the reason why I gave you all of that is because you're going to follow a similar pattern for the following. All right. In fact, let's go ahead and read number 4. Katie's making lemonade. And again, if I'm going too fast, I encourage you to pause this video. And maybe if you want to try some on your own, you can move on forward if you feel like you got the hang of it. Otherwise, you can pause it, read it, see if you can figure it out on your own, and then come back to the video and let's see if you made sense of it. So Katie's making lemonade from a powder mix. The ratio, okay, that's important, ratio of scoops of powder mix. So we're going to be mixing the powder mix to water. Those are the two things that we're comparing. Powder mix to water. Powder mix to water is 4 scoops of powder mix to 1 gallon. So scoops to gallons, So scoops of powder mix to gallons of water. Okay, so you can either write powder or water. I'm going to use scoops in gallons. So what are the two things that we're comparing here, ladies and gentlemen? Let's go ahead and write that already. We're comparing scoops. It looks like a 5, but that just says scoops. In fact, I'm going to rewrite that. I don't want to be confused. We have scoops. There you go. To water. Actually, I'm going to write gallon. Gallon. Scoops to gallons. And that ratio of scoops to gallons is 4 scoops for every 1 gallon. 4 scoops for every 1 gallon. So notice that I'm working sideways. And I'm just making fractions, and anything having to do with scoops is going to go on the top. Anything having to do with the water is going to go on the bottom. All right, so now we're going to use this pattern, this formula for the following problems. So number 1, or letter A, how much water would Katie mix if she uses 12 scoops of mix, 12 scoops? So obviously, I'm going to put the 12 into this and ask yourself, where's the 12 going to go? Is it going to go on the top or is it going to go on the denominator? Think about it. Well, obviously, the 12 is going to go on the numerator because that's where scoops is. And it's 12 scoops. So just like the 4 scoops were on top, the 12 scoops need to go on top. And it's asking how much water. In other words, we don't know how many gallons of water we're going to need. We have 12. All right, let's go ahead and solve this problem, ladies and gentlemen. Again, what do I have to do to the 4 to get to the 12? Ask yourself that. Well, I believe you have to multiply it by 3. So 4 times 3 is 12. Notice how we're following the exact same pattern that we did in the previous problem. So that means that I have to multiply the denominator by 3 to get our denominator. So 1 times 3 is 3. So that means that for 12 scoops of mix, I need 3 gallons of water. X has to equal to 3. X has to go to 3, and that's what you would put on Schoology. So that would be 3 gallons of water. Now let's look at letter B. How much powder? Letter B. How much powder? So now we're looking for the powder. Should Katie use if she plans to use 5 gallons of water? Okay, so we're following a similar pattern here. Okay, so well, we're going to follow the exact same ratio. So we have scoops and gallons, and we have the same ratio, 4-to-1, 4 scoops for every 1 gallon. However, this time we're using 5 gallons of water. So I'm going to put the 5 on the bottom, and they're asking, well, how many scoops would that be? So ladies and gentlemen, this time we're going to use, it's the exact same pattern. I'm still using the same ratio, 4-to-1, but this time we know that we have 5 gallons of water, and we're asking, well, how many scoops is that going to be? So ladies and gentlemen, you are going to do this one on your own. Ask yourself, what do you have to do to the 1 to get to the 5? Do the same thing to the 4, and that'll give you your answer. All right, so I'll let you guys do that on your own. I'm going to move on to the next one. Number 5. Number 5. There are a total of 60 plastic blocks. 60 plastic blocks. Notice that that's the total. So that's important. It says 3 out of every 5, that's a fraction. So 3/5 are red. Okay, 3/5 are red. Now the question is asking, is it reasonable for Brianna to think that there's enough red blocks to make a design that uses 32 red blocks? In other words, does she have enough to make a design? Does she have enough red blocks to make a design that requires 32? So she needs at least 32 blocks. She needs at least 32. Well, let's see what's happening here. We're comparing red blocks, red, to the total. That's the two things that we're comparing here. Red to total. And ask yourself, do we know the ratio of red to total? Okay, I know there's a total of 60. But we don't know the total number of red blocks. We know the total is 60. But notice that they do give us a ratio. 3 out of every 5 are red. So that means that if we have 5 blocks, 3 of those will be red. That's exactly what that means. 3 out of every 5 are red, means that 3 are red out of every 5 total. That is the ratio that is given to us. I know it's kind of worded a little bit weird, but that's exactly what that means. 3 out of every 5 are red. Just like if I said in the classroom, 3 out of every 5 people are wearing jackets, I'm saying that if there were only 5 people, 3 of them are wearing jackets. So in this scenario, 3 out of every 5 are red means that if there's if there's 5 blocks, 3 of them are going to be red. But the question is now asking, well, if we have 60 total blocks, how many of those would be red? How many of those would be red? So I want you to figure that out on your own using the same method that we did previously. And then once you find out how many total red blocks there are, ask yourself, do we have enough to make the design that requires 32 blocks? It's a simple yes or no question. So I'll let you guys have fun with that one. So as you can see, it's not really that hard of an assignment. Now, number 6, which of the following is not a ratio, so you can figure that on your own. Number 7, make sure you're reading carefully and you're counting the shapes here for number 7 carefully, because you're going to be using that. You're going to be using comparing the stars to the number of circles, stars to circles. So I'll give you a hint. Make sure you have stars on top and you have circles on the bottom. Or you can have stars first, circles after that, or you can have stars to circles. That's how the numbers are going to be organized once you count the number of stars to the number of circles. Same thing in number 8. In number 8, you're now comparing shapes to the numbers of arrows. Notice that the squares are shapes. So we have squares and arrows are both shapes. We have black squares, white squares, and black arrows. So make sure you're paying attention to the things that it's asking you to compare. For number 8. Moving on to number 11. This one may seem hard. It says complete the ratio table that shows the ratios equivalent to 9 to 33. And then we have all these numbers right here. Well, ladies and gentlemen, 9 to 33 is simply a different part of this table. In fact, we have 9 on top and 33. In fact, I'm just going to extend the table here like that. And you're going to use this ratio to complete this table. And I'll help you with the first part. For example, remember, all of these can be seen as fractions. So if I look at this first one, 45 over what is the same thing as 9 out of 33? Well, I know that I can multiply 9 times 5. 9 times 5 is going to give me 45. So if I multiply 33 times 5, that should give me what goes down here. All right, well, 33 times 5, let's work that out. 33 times 5, 5 times 3 is 15. 5 times 3 is 15, plus 1 is 16, so that would be 165. So that means that 45 over 165 is the same thing as 9 over 33. And that's exactly what you would put on Schoology on number 11. Notice that the first blank is actually not that one, but that blank would be C, and that would be 165. Why don't we do this next one? A, which is this blank over here. Let me change the color. We're going to look at this blank over here. It's asking what over 330, and here let me erase these things so that we're not as cluttered. We have 9 over 33, right? It's asking what over 330 is the same thing as 9 over 33. Well, I know that if I multiply 33 times 10 times 10, that's going to give me 330. So obviously I need to multiply 9 times 10, and that gives me 90, which makes perfect sense. That 90, notice the similarities, 933, 90, 330. Should be the same thing. So ladies and gentlemen, you're using that same pattern to fill this table, okay? I believe they're all going to fit evenly. And again, you don't have to use 933. For example, once you figure out this one down here, because it's a smaller fraction, it might be easier to use to fulfill the table. But I'll let you guys try to figure that out on your own. Number 12, you're going to ask which of the following ratios is not equivalent to 933. Ladies and gentlemen, all I can say is that you can cross multiply. Anytime you cross multiply, I would use 933 for each one of these fractions, and you can cross multiply them to see which of those is not equivalent. And moving on to number 13, the ratios 4/5, that's a fraction, 4/5 and x over 80 are given to you. 4/5 and x over 80. And it says that they are proportional. In other words, they need to be equivalent. So you need to ask yourself, what over 80, what number over 80 is going to be equivalent to 4/5? There, ladies and gentlemen, you can use either method that we've used. You can either cross multiply and then divide. For example, I can use this to make an equation. I can do 5 times x, 5x is equal to 4 times 80, which is actually going to be 320. And then you can divide both sides to isolate the variable, or you can simply ask yourself 5 times what is equal to 80 and do the same thing to the numerator. Both methods will work, and that'll give you the value of x. And then finally, number 14, you're only doing 14C. You're using that exact same method to find the value of x. Don't worry about the graph. We'll talk about those later. So that's pretty much it, ladies and gentlemen. Hopefully you find this assignment is not too difficult. If you guys have questions, I can address them when I do get back. But with that in mind, I will see you next time.